Okay, guys, this is the last topic of our unit, our stoichiometry unit, which we've so far talked about moles to grams, grams to grams, conversions, balancing equations. This is the last topic. So one thing that we talked about in earlier class periods, earlier lessons, is the difference between a reactant and a product. In this reaction, we have hydrogen and water forming, hydrogen and oxygen forming water. So the hydrogen and the oxygen are both reactants. They react together to form water, which is our product. So we're going to be focusing on the reactants of chemical equations, chemical reactions, and figuring out which one will be totally used up and which one will be in excess, or which one will have extra. Okay, that's kind of the point of this last topic. Every time we have a chemical reaction, one of the reactants will be used up, one of them will be in excess if there's two reactants. So the one that's completely used up is called the limiting reactant. The one that we have extra of is called the excess reactant. But where did our whole story of stoichiometry, our whole story of this unit start? It started at the bike factory. So you might not have known it, but there's this fancy Italian bike bike company called the Mastini Bike Company. And this bike company actually buys wheels and buys frames from distributors. So what we have here is we have other factories. We have a wheel company over here, and we have a frame company over here. So the way that this works, and this is all super complicated bike terminology, and bike information, trade secrets. The Gambini Wheel Company delivers wheels to the Mastini Bike Company, and they deliver those wheels in big trucks, and each truck has two wheels that they deliver the wheels kind of in sets of two. So you have kind of like packages of wheels in sets of two. So wheels from the Gambini Wheelwork Company come in sets of two. And the Edmund Frame Incorporated, they send us, the Mastini Bike Company, they send us frames, and they also send those frames. So here's one frame right here. They send the frames also in packages of two, okay? So when the frames and the wheels get to the Mastini Bike Company, the workers have to kind of like unpackage all the frames and unpackage the wheels in order to make the bikes. Okay, so that's the first thing that we have to realize. The second thing is we can kind of write an equation about how to make a bike, kind of like we did before, but a little different. Knowing that wheels come in kind of packages of two off the truck, and frames also come in packages of two off the truck, we can kind of make an equation for making a bike. So our bike making equation is going to be, let's see, we have wheels plus frames is going to produce a bike. And a bike, we're going to say, is something with two wheels and a frame. Okay. So, I don't know, doesn't really seem right, because this equation is kind of saying that two wheels and two frames give you one bike. That's not really the case. A bike is two wheels and a frame, not two wheels and two frames. So what we've run into is an unbalanced equation. So even with these sort of problems, the first thing we need to do is to balance out this bike making equation. So we kind of try to figure this out. So I think we need a 2 here, and we need a 2 here, and I think we're balanced out. Let's double check. So wheels and frames on one side of our equation. On our reactant side, we have 4 wheels, and on our product side, we have 4 wheels. We have 2 frames and 2 frames over here. Okay, so I think this is balanced now. So the last thing I'm going to write down here is the idea that this is sort of like 2 packages of wheels right here, right? 2 packages of wheels off the truck. And the middle one is kind of like 1 package of frames. And if we can take 2 packages of wheels and 1 package of frames, we make 2 bikes. So 2 packages of wheels plus 1 package of frames means that the Mostini Bike Company can make 2 bikes. Another way to think of this is visually. If you had 2 packages of wheels and 1 package of frames, oh, I drew that wrong. You could produce 2 total bikes. So there's our balanced equation. Now what we're going to do next is we're going to come up with a situation that might happen if you are the head receiving manager for the Mostini Bike Company. If you're the guy in charge of unloading the semis with wheels and frames. So, Mr. Shipping Manager, let's say that you just received a shipment of 200 wheel packages and 175 frame packages. How many bikes can you make? Well, in this scenario, there's kind of like 2 cases, 2 situations that could happen. Let's talk first about case 1. Case 1 is that all the wheel packages are going to be used up, and there are enough frame packages. So there's enough frames to use all of the wheels up. So that's case 1. Case 2 is kind of similar. Case 2 would be that all the frames are used up making the bikes, and there were plenty of wheels, or some wheels left over. So both cases can happen. You're either going to use all of the wheels, or you're going to end up, and there'll be plenty of frames left, or you're going to use all the frames and there are plenty of wheels left over. I guess there's the slight possibility that you could use, that you have the perfect amount of wheels and frames, but that usually just doesn't happen in the real world. So let's figure out how many bikes you can make with case 1, and then how many bikes we can make with case 2 to figure out which case will actually occur, which situation will actually happen. So we can use a simple ratio here to figure out how many bikes we're going to be able to make, since we have a balanced equation for bike making. So we know that we have 200 packs of 2 wheels. So each pack comes with 2 wheels, and we have 200 of those packs. And if we set up wheels down here, for every 2 packs of wheels, we can make 2 bikes. So if we have 2 packs of wheels, that's like 4 wheels. If you have 4 wheels, you can make 2 bikes. So that's where this ratio comes from. And if we use our the math we've been doing so far this unit, we can say 200 times 2 divided by 2, and we have bikes as our leftover unit. That's going to be 200 bikes. So case 1 yields 200 bikes. Let's check case 2 to see how many bikes we make there. So in case 2, we're saying that all the frames were used up and there were plenty of leftover wheels. So let's go ahead and set our units up. Frames down here and bikes on top. We know that for every 1 frame, we can make, 1 package of frames, so that's like 2 frames in a package. We can make 2 bikes. So for every one package of 2 frames, we can make 2 bikes. If we cancel out the frame unit, we're left with 175 times 2 divided by 1, and our unit is bikes. If you multiply that together, you end up with 350 bikes. Oops. So, case 1 produces 200 bikes. Case 2 produces 350 bikes. Which case actually occurs? Which one actually happened? In case 1, we have enough material to make 200 bikes because we have 200 wheel packages. But in case 2, we have enough frames to make 350 bikes. Here's the problem. Case 2 can't happen because it would require 350 wheel packs. We only have 200 wheel packs. We only got 200 wheel packs in our shipment. So that means that case 1 is more realistic. We get 200 wheels, and we'll use all of the wheels up, and we'll be left over with some extra frames. So in this case, if we answer the question, how many bikes, how many W2Fs can we make? We can make 200 bikes. We'll have extra frames because we kind of got more than we needed. But we'll use up all of the wheels. In other words, case 1 tells us that the wheels are considered our limiting reactant. It limits the amount of bikes that we can make. Whereas the frames, we had extra. So the frames are what we consider our excess reactant. So this idea of getting reactants or from suppliers and making something in a factory, it's the same sort of idea we can apply to chemistry. Because in chemistry we have reactants before the reaction happened, and then we end up with a product, kind of like the bikes were in our problem. What we're going to do is we're going to do one example. Instead of using frames, wheels, and bikes, we're going to use water. Here's the reaction for when we have hydrogen gas plus oxygen gas to make water. Looking at this reaction, hopefully you see right away that it's imbalanced. So we need to balance this equation. How? That can be achieved by putting a 2 here and a 2 here. So in other words, 2 hydrogen molecules plus 1 oxygen molecule will give us 2 water molecules. Let's say that I had a water making factory and I had to import some hydrogen and oxygen gas to make that water. And let's just say I had this much hydrogen. So that's 4 H2s, or in other words, if we added all the H's up together, that'd be 8 total hydrogen atoms. And then I also imported some oxygen. So let's say we've gotten 5 oxygen molecules. Or in other words, that's 10 total atoms of oxygen. So the question is, how much water can I make? How much water can I make in this situation? How many water molecules? Are the hydrogens going to get used up? Or are the oxygens going to get used up? Or do I have the right exact amount of oxygen and hydrogen to use all the hydrogen and oxygen up? So let's set up a case 1 and case 2 for each of these. All right, case 1 is going to be our hydrogen. So we're going to say we have 4 H2s. How many H2Os will we end up with? So our ratio from our balanced equation is 2 H2s for every H2O. My H2s cancel out, and I'm left with 4 times 2 divided by 2. So that equals 4 H2Os. Now let's look at case 2. So case 1 was all the hydrogens get used up. Case 2 is all the oxygens get used up. So we'll go ahead and use our ratio again from the balanced equation. For every 1 molecule of O2, we make 2 molecules of H2. O2's cancel out, and we're left with 5 times 2 over 1. That's 10 molecules of H2O. So, which case actually occurs? Well, in case 1, we used up all the hydrogen, and we only got 4 waters. Case 2, we used up all the oxygen, and we got 10 waters. So which one could actually work? The answer is going to be case 1. Case 1 is going to work because we've used up all the hydrogen and we have leftover oxygen. Case 2, on the other hand, we used 5 oxygen molecules. And we made 10 waters, when before, if we used up all of our hydrogen, we were only able to make 4 waters. So this is not the amount of water we make. We end up making 4 waters. Don't believe me? Well, let's draw it up here. All of these waters over here, or I'm sorry, all these hydrogens over here are going to be used up according to case 1. So let's draw them all in. Each set of hydrogens, each pair of hydrogens are going to be paired up with 1 oxygen. And there we go. There's our H2O that we were looking for before. So in this case, we used 4 hydrogens. I'm sorry, we used all 8 hydrogen atoms, and we only used 4 oxygen atoms. We had 10 oxygen atoms in the beginning, so that means that we have 6 oxygens left over. What that means in the long term, or the important thing here, that means that all of the hydrogens were used up. That means it's the limiting. It's called the limiting reactant. So hydrogen is our limiting reactant. Whereas we have extra oxygen. So that means that oxygen is our excess reactant. Reactants are things that are on this side of the equation. And we know that oxygen is an excess, extra, and hydrogen is limiting. If you tried to draw case 2, you wouldn't be able to do it because you'd run out of hydrogen atoms. You wouldn't have enough. So there's your conceptual explanation of limiting reactants. We'll do more of these. We'll do a POGL on Monday. We'll also work more on the math Monday evening with another video.